Hello everyone, I'm Ankit from Electronics and Computer Engineering branch. For capstone project, I did research work under the guidance of Dr. Gitanjali ma'am. My research project is DDoS attack detection in SDN using entropy.
Before directly jumping onto attack detection, let's first understand what software-defined networking, or in short SDN is. SDN is a three-layer architecture with central intelligence that we call SDN controller. By detaching the data plane from the control plane, the SDN architecture simplifies the job of a web administrator by providing a programming interface for application development related to administration, safety, and dependability, and many other things. More access over the total network is provided by the centralized controller. The SDN and its benefits exposes the network to the threats and outcomes of these security concerns are very dangerous as compared to traditional networks. One of such attack is DDoS. A distributed denial of service attack is a malicious attempt to disrupt the normal traffic of a targeted server, service, or network by overwhelming the target or its surrounding infrastructure with a flood of internet traffic. Basically, as in this case, a large number of packets are forwarded to a network device host H1 from attacker for stopping the services, decreasing the performance, and spoof the packets from sent to controller, and flow table is updated every single time. The detection of DDoS attack must be early. The term early is subjected to tolerance level and traffic being handled by the controller. And the early detection is needed because it results in controlling flooding of malicious packets significantly. The early detection mechanism must be lightweight and should have high response. The high response time helps the controller in regaining the control during the attack. Detecting the entropy variation in the destination address could be one of the possible solutions. A sample entropy, a general method for DDoS detection in SDN, is conducted by collecting the flow statistics of traffic features from the switches and calculating the entropy measure randomness in the packets that are coming to a network. The higher the randomness, the higher is the entropy and the vice versa. By setting a threshold, if an entropy passes it or below it, depending upon the scheme, an attack is detected. But why entropy method? Variety of methods are available to perform detection of DDoS attack. A ML-based approach can be employed, but solution must run concurrently with SDN after each alteration in network and then trained for several hours. Snort method can be used for DDoS attack detection, which is not based on SDN. This method takes control over the entire controller. Detection using network intrusion detection systems (NIDS). The method requires installation of NIDS devices, which increase cost as well as computations. So I came to conclusion that for SDN, entropy method is an effective, simple and quick mechanism that is also lightweight in number of resources utilized. Now let's study the algorithm. Each 50 packet signals are passed for the destination IP address, and thus the entropy of the list is calculated. After then, the computed entropy would be checked to a threshold. An attack is detected if the computed entropy is below the threshold and lasts for at least 5 successive entropy cycles. Detection inside 5 entropy cycles is 250 packets in the attack. Providing a network with an early warning of an assault, we tested with values ranging from 1 to 5 successive cycles, with 5 yielding the lowest false negative and positive rates for timely identification. For setting up the emulation environment, a Mininet is used as a network emulator for rapid prototyping of software-defined networks. It supports Python API for network construction, exploration, and experimentation. POX is a Python-based controller. It is a quick and lightweight controller. It is commonly used for research work, experimentation, and demonstration. Scape is a Python application used for packet generation. It can also decode packet, transmit them over the network, collect them, and also compare requests and responses. For analysis, a network of tree topology of 4 switches and 9 nodes directly connected to switch were set up using Mininet. Now the POX controller generates a collection of entropy values. The typical threshold entropy is the lowest value obtained. Then traffic is launched by running the set of commands in H1's extern window to initiate the attack. Those set of commands are simultaneously run in other host extern windows such as H2 host or H3 host. Now the entropy values are observed in the POX controller. When the values decrease below the threshold value for normal traffic, we can detect the attack within the first 250 packets of malicious type of traffic attacking a host in a SDN network. We successfully implemented sample entropy method to detect DDoS attack. This solution is not only efficient in detection, it has minimal code addition to the controller program and does not increase CPU load in either normal or attack condition. Thank you.